So that's basically it. You made it. You learned about these 6 major routines in the context of data preparation. As I said, they allow you to solve basically 90% of all the data preparation tasks you usually encounter in daily practice. The big art is to know when to use which of the routines. I guess this is something you just learn by experience. So you just need to practice, and then this data preparation will become more and more easy for you. And what I want to do right here is to look with you at a final example, which is a bit more complex than what we've encountered so far. To walk you through that example, to give you an idea of how actually tasks that at first look very complex can become very easy if we piece them down into small steps then that themselves are rather trivial. So the idea is to start with this data set, data final expo, which is rather long, as you see. It has 88 rows. And to compute the difference in the country averages for all variables for the time periods 2005 to 2007 and 2010 to 2013. So what we need to do is we need to take this data set. We need for each country, we need to compute the average unemployment and GDP for the period 2005 and 2007 and the period 2010 to 2013. And then we need to compute the difference. Wow, okay, that might sound quite complex at first sight, but we will see that once we piece it down to small steps, it actually becomes quite easy to solve. So yeah, just hang in there and let's go. First thing, when you get a task like this, it's always important to get a good overview about the data set you're dealing with. Especially if it's a long data set, you might use this function head that only prints the first 5 rows. So you get an overview about this data set. You might use the function str, which gives you an overview about the structure, where we also see the different types and get a preview of all this. But it's also useful in this context. You might use the function unique, where you then use the the name of the data set, and then you can extract certain columns to get the unique values. So you might wonder, okay, how many different countries are there actually? So, okay, there are 5 different countries. This gives you a better understanding of how the data set looks like, and it helps you actually to check whether what you're doing is actually right. But now that we know more or less what kind of data set we are dealing with, let's get started. So keeping in mind that we are asked to compute averages for the time periods 2005, 2007, 2010 to 2013, the first thing we need to do, we need to somehow add information to this data set with regard to which period the observations refer to. Otherwise, we can't compute averages, because when we want to compute grouped averages, we always need a grouping variable. And right now in this data set, there's no grouping variable that identifies these 2 periods. So let's say, okay, we have solution step 1. And the idea of solution step 1 is to add a grouping variable. So this is also something that you might write down as a comment. That is helpful for you not to lose track of what you actually want to do. In our case, we want to start with a data set and we want to add a grouping variable. So since we want to add a grouping variable, what we need to do, we need to call the function mutate, because adding a new variable always means to use the function mutate. And we now need to have new variable that somehow identifies these periods. How can we do it? So we call this new variable period, and we now need a function that allows us to assign a value to that period based on the year that's in there. Now, if you remember, we encountered this function if-else before. If you don't remember, that's perfectly okay. If-else is a function that allows us to specify a test and then returns a different value depending on whether this test returns true or false. So let's illustrate it with an example. So we could use the function if else. The test is that 2 is bigger than 5. If this is true, it should return the string well. And if this evaluates to no, it should return the string okay. So in this case, obviously 2 is not bigger than 5, so it returns the string okay. If we've changed here the condition, like 2 is smaller than 5, obviously the function will return well. Now what we want to do here is our test here is that the column year is in the period 2005 to 2007. So we can write year is in the set 2005 to 2007. In case you don't remember how this works, you might have a look again at the helper functions in the context of creating vectors. So using this double colon here simply creates a vector with the years with the numbers 2005, 6, and 7. So it's just a shortcut for the sec function we've encountered before. And yeah, so if this is true, let's say we want to call this period early. And if this is not true, then we need to, we can use the period late. At least we should try whether this works. This is always very important. Just you should often just try out things and see whether it works. If we now look at the data set, we immediately see that this is not exactly what we wanted. So what does work is that here 2005, 6, and 7, they are in the early period. This is exactly what we wanted. But now here year 2000, 2002, etc., they are in the late period. And this is because the data set contains data that is before 2005. Now there are different ways of how we could address this. We could either filter all the data that is not in these time periods before actually calling the if-else function, or we could add a second if-else statement here, where we say, okay, if the first test is not successful, we call for a second if-else statement where we say the test is this time year in 2010 to 2013, and if this is true, we say we are in the late period, and if this is not true, we say we are in no period. Especially if you use these kind of nested calls, it's good to work with the indentations to make it more readable. If we call this right now, we see that it seems to make sense, right? We can also use this function view to get a bigger overview about the data set. And here we see, okay, that really seems to make sense. If we sort according to the period, we see, okay, here we only have observations for 2005 to 2007, 2010 to 2013 are always encoded with late, and all the other years here get the value no period. And what we then can do in the next step is we could filter the data, but let's do it separately. Let's say, okay, we have another step where we filter out the irrelevant years, and we say, okay, we have solution step 2. that builds on solution step 1. And we now use dplyr filter, and we filter out all the observations where period equals to no period. So in this case, we say, okay, we filter period is not equal to no period. Why? Because we want to filter out, we only want to keep those rows for which this is true. So in this case, again, we just execute it and we can again have a look at the result. At first sight, it looks correct. So then we can also use the view function. Here we see that only those dates and country combinations that are of interest are in there. We could also use the function unique and check whether indeed with period we only have early and late period in there. So we made some progress with regard to our overall goal. We have added a grouping variable with the 2 periods. So what we now need to do is we need to compute the average of the variables. Now we have 2 variables here, and there are in principle 2 ways of handling this. We could either make the data set longer and then group by the variables and compute the means, or we say, okay, we do a summarize call directly. And I think the latter one is probably the better option. If you don't agree with my approach of solving this task, feel free to go for your own path and try it out and maybe come to the same conclusion as I do. So that's actually good practice, trying to find a different solution. So let's say, okay, we now want to summarize according to the period. So we have solution step 3 that takes solution step 2 as an input, and we now want to summarize our data set, and we want to summarize the unemployment mean, which is the mean of unemployment. And we also want to get the GDP mean, which is the mean of GDP. In both cases, we want to group by country, and we also want to group by period, because we need to compute the differences in country averages over the different periods. So let's see whether this actually works. Okay, that actually looks pretty good. So we have for Austria a mean for the early and the late period, the same for Germany, Greece, Italy, and we have here mean values for unemployment and the mean in GDP. So that actually looks pretty nice. What we now need to do is we need to compute the difference in the averages. So we basically need to subtract the early value from the late value. This is nothing that we can do in a data set in this form, because we can't subtract row 2 from row 1, etc. We would need to make this data set a little bit wider, because what we can do is like subtract one column from the other. So we should now reshape the data to get an early and late period columns. Now to do that, we first need to make the dataset, however, longer, because GDP and unemployment mean need to be in different rows. So we need a 2-step procedure. So let's say, okay, solution step 4. First of all, what we will do, we will call pivot longer by making the columns unemployment mean and GDP mean by taking these columns And by saying, okay, the names too, they should go to, let's say, the indicator, and the values should go into the column called, I don't know, let's call it means. Not strictly necessary, but makes it more transparent. Okay, this does look nice. What we then need to do is we now need to make it wider, in the sense that the periods should get their common columns. So now we make a pivot wider call, where we say, okay, we take the names from the column period, and we take the values from the column means. And if we look at that, okay, that looks much easier to handle, because now we can basically compute the difference between late and early by just computing the difference between the columns. So we have a solution step 5, where we now have call from mutate. So let's call the new column difference, and that's just late minus early. So if we look at solution step 5, we actually have here our column difference. Now let's see, compute the difference in the country averages for the variables for the time period 2005, etc. So that is basically more or less what we wanted. We could say, okay, make it more pretty, yeah. So, I mean, this is not really nice to read. So what we could do is we could have a solution step 6, where we say, first of all, we say we deselect the early and late column, because we don't need that anymore. So we have it like this, and then of course it might be nicer to have the columns to unemployment and GDP to see a little bit more directly of what the difference actually is. I mean, that's not perfectly necessary based on the formulation of the task, but I think it's nicer to say, okay, take the names from the indicator column and the values from the difference column. And if we look at this, okay, the result seems to be much more clearly, much easier to read. Of course, you might say, okay, I don't like the name of these columns. So what you could also do, this is a function. It's usually not very necessary to do so, so I haven't introduced it so far, but just as a bonus, we could use the function called rename that allows us to rename columns. So we could say the difference unemployment, so we write the new name equals the old name, and we have GDP as the new name and GDP mean as the old name. If we look at this, okay, maybe it looks a little bit nicer, and we learned about the function rename, which might be handy in practice sometimes, whatever. In any case, we basically solved our task, which is much more important. So as you might have figured out, this thing that looks very differently in the first place, so starting from this to go until here, required us to take quite a lot of steps and to combine many of the routines that we have encountered before. But if you think about it, every single step in itself is not that difficult once you've heard about the functions that we use there. I think this is really the art of data preparation, and that is maybe also the biggest lesson that learning a programming language bears for you in real life, that difficult tasks become much more easy once we boil them down into small trivial steps. Or put differently, the difficulty of a big task is much more than the sum of the difficulties of the small tasks, because small tasks can be easy. But when you chain many easy tasks and you want to solve them all together at the same time, it becomes very difficult. So what you should do in situations like this, and probably also in real life, once you encounter a task that's super difficult, don't think about how to solve it immediately. Think about how you can separate it into smaller tasks, and then think about how to solve the smaller tasks. And then step by step, you will come up with a solution for the big task that in the very beginning you could never have thought of yourself. I hope so that this small example here actually illustrates this bigger philosophical point about real life and tackling problems that are difficult or not that difficult. Anyway, I hope that clarified at least how you can combine the 6 data preparation routines we were talking about. And my recommendation for you would be look at the solution here, rebuild it for yourself, make sure you understand the different steps, then maybe even combine the different steps using pipes into one particular call, and then do some of the exercises. And even data preparation might look like a very difficult thing in the very beginning. Believe me, once you practice this a bit, it becomes really, really easy. And sometimes it's even fun. You might not believe it right now, but actually I now really enjoy solving these kinds of data preparation tasks, which is really cool, because it's something you need to do all the time when you work with data, especially in the context of data science.